Hi everyone, welcome back to my shop. Thanks for tuning in. In this video, I'm going to be making a new Cyclone out of one of these 55-gallon cardboard drums. And I'm going to be making a Thien Baffle type Cyclone. Now what this is instead of having, like a big commercial type Cyclone with the cone at the bottom, this has a flat plate just down from the inlet with part of the circumference cut out that allows the dust to pass through. It's a lot more compact vertically and has, roughly comparable performance to more of a typical Cyclone. I built one of these a couple of years ago for my shop vac, which I was using as a dust collector at the time, and it does a good job of separating out the bigger chips and keeping them out of the filter. So for this one, I'm making a scaled up version to go with my new dust collection system, which I've shown in a previous video. Anyway, let's get into it. For the inlet of the Cyclone, I'm going to use one of these 10" by 4" register box fittings, since the 6" round duct tapers off nicely in it. The idea here is that it will intersect with the side of the Cyclone and allow the chips to enter at a tangent. Due to the curvature of the piece, it doesn't quite fit in the rectangular opening, so this needs to be widened a bit. To create a sort of flange connection on the inside, I'm cutting tabs into the fitting. These tabs can then be bent over and hammered flat against the side of the drum. To firmly attach the fitting to the drum, I'm going to use some 1/8" thick plywood strips to act like big washer plates to pull everything flat. I'm using construction adhesive here since it's more gap filling and will adhere to the metal better than wood glue. This metal tab I left long to provide a smooth surface for chips to glide against, so I'll glue this in place. Now for the plywood strips on the bottom part of the flange. Since I don't have a clamp that's long enough, I need to fasten these on a bit at a time. Next, I use more of the construction adhesive, like caulk, to fill the gaps around the fitting. After the glue dried, I cut the long ends off these machine screws to keep from scratching myself. Now it's time to make the actual Thien Baffle, for which I'm using some 1/2-inch plywood. This is generally circular and should be slightly smaller than the inner diameter of the drum. Next, I divided the circle into thirds by keeping the same radius on the compass. 2/3 of the baffle has a circumferential slot cut into it, which allows the chips to fall through as they spin around the Cyclone. Next, I marked for 3 holes for the threaded rod that will hang this from the lid. To reinforce the lid, I'm cutting some plywood pieces that will glue to the bottom. I don't have a big enough piece of plywood to cut this hole, so instead I'm cutting 2 semicircles. Off camera, I found a better way to Tetris these pieces on the board, so that's what I'm cutting out now. Drilling now for the hanging holes in the baffle. I measured from the top of the drum to the bottom of the inlet, which was about 8 inches. Adding another 2 inches for the bolt grip, the pieces of threaded rod need to be about 10 inches overall. And of course, I broke the blade of my bandsaw cutting the second one, so I had to use a hacksaw on the third off camera. Next, I found and marked the center of the lid. Then I used the baffle as a template for the matching holes and marked those as well. Apologies for the unfocused camera work here, but I'm drilling through the lid with a metal cutting drill bit, and then following with a brad point bit for cleaner holes in the plywood. This 6-inch takeoff will be the outlet for the Cyclone, so I measure and mark the hole in the lid for it. I cleaned the lid with some acetone before sticking the outlet to it. I really should have done this part before cutting the hole for the outlet, but now I'm measuring for some viewports in the top of the lid. These will be covered in plexiglass and allow me to see the Cyclone in action, and also let me check the level of chips in the drum without needing to pull the lid off. I used the cut-off pieces of the lid to mark for the plexiglass covers, and then oversized them by about a ½ inch to allow for fasteners. Here I'm using more construction adhesive to act as a gasket on the perimeter of these windows, which will seal up when I screw them down. Before hooking up the new Cyclone to my system, I want to benchmark it to see what kind of performance hit I get. I realized as I was editing this video that I had a blast gate open in my system, so I'm not getting the full airflow and suction that I should be. So this is really only for comparative purposes. Airflow is about 3,000 feet per minute, and the static suction is about 3¼ inches of water. That equates to about 590 CFM. Time to take out the old collector and put in the new Cyclone. I'm mounting the motor to the ceiling, which turned out to be a giant pain. You might be wondering why I didn't just mount the motor directly to the lid. From what I've read online, the motor shaft for these Harbor Freight dust collector motors don't have thrust bearings, so any prolonged axial load on the shaft can cause failure of the motor. I've seen lots of videos where people do this for their dust collectors and it seems to work, so who knows. I couldn't find any of my ratchet straps, so I'm using some paracord as a makeshift hoist to bring the motor up. This is pretty precarious, as you can see, so I don't recommend it. With the new Cyclone in, time to see how the airflow changed. Again, I goofed up and left one of my blast gates open, so these aren't the real numbers, they're just for comparison. My airflow dropped to about 2,000 feet per minute, or 390 CFM, and the static suction to maybe 2 inches. Anyway, with the new Cyclone hooked up, time to test it out. You can see through the viewports that the dust swirls around the drum and falls through the slot I cut, as per the design. Alright, that'll about do it for this one. The Cyclone is all done, and it's so far separating chips nicely. There are still a couple of modifications I want to make to the motor mounting and all that. It turns out that this motor's not very well balanced and it really shakes the floor above. So what I'm going to do is flip this around and then mount it on a little stand to the floor just to cut the vibration out. And I think I'm also going to replace the impeller on the blower side so to get some better suction and airflow out of it. But that'll all be in a future video. Anyway, thanks as always for watching. Don't forget to like and subscribe, and I'll see you next time.